Hello and welcome. Today, we're exploring a fascinating evolution in robotics, moving far beyond the typical rigid machines we often picture. Robotics is entering an era of incredible adaptability and resilience, driven by exciting frontiers like swarm robotics and soft robotics. Let's start with swarm robotics. Imagine large groups of relatively simple, small robots coordinating their actions, much like an ant colony or a flock of birds. This isn't about one central controller, it's about decentralization. Decisions are made through local interactions between robots. This approach has amazing advantages. It's scalable, you can add more robots easily. It's robust. The failure of a few robots doesn't stop the whole group. And often, the individual robots are simpler and cheaper to build. Because they work as a collective, swarms are perfect for tasks covering large areas or exploring unknown, even hazardous environments. Think about deploying swarms for environmental monitoring, tracking pollution, or mapping terrain. They could navigate disaster sites for search and rescue, where larger robots can't fit, perform precision tasks in agriculture, or even assemble structures. Some researchers envision tiny swarms navigating inside the human body for diagnostics. Of course, designing the rules for this local coordination and ensuring communication remain challenges. Now let's pivot to soft robotics. This field takes inspiration from flexible biological organisms like octopuses or jellyfish. Instead of metal, these robots are built from compliant materials. Think silicone, rubber, or special polymers. This allows them to bend, stretch, twist, and conform to their surroundings in ways traditional robots simply can't. The key benefits here are compliance and adaptability. Soft robots can navigate complex, unstructured spaces and handle delicate or oddly shaped objects with ease. Crucially, they are inherently safer for interaction with humans because they lack rigid parts. They're also resilient, often able to withstand impacts that would damage a conventional robot. Applications are incredibly promising, especially where traditional robots struggle. In healthcare, we're seeing gentle grippers for surgery, wearable rehabilitation devices, and even ingestible tools. They could lead to much safer collaborative robots in our homes and workplaces. Their flexibility allows them to squeeze through tight gaps for exploration or handle fragile items like food products in manufacturing. Challenges exist, particularly in precisely controlling these deformable bodies and developing efficient soft sensors and power sources. But what happens when we combine these ideas? Imagine swarms of small, soft robots, each able to adapt physically, working together on complex tasks. This synergy could revolutionize areas like minimally invasive surgery or environmental cleanup. Both swarm and soft robotics represent a fundamental shift, promising robots that are more adaptable, resilient, safer, and capable of working in challenging environments, often right alongside us. The pace of innovation is rapid, truly pushing the boundaries of what machines can achieve.